Now today we're going to talk about the different types of reactions that are involved. And I'm going to fast forward. I know that there's some blanks on here. Let me scroll down to right before the homework. These particles here in first hour, they're like, do we have to memorize this? Yes, you have to memorize these. And again, we already worked with the neutron. We were working with the proton yesterday as well as the neutron. Now, some of you might go, whoa, aren't these the same? Yeah, they're the same. They're just, again, has a different name. So beta particle is an electron. Make sure you know these, yes. So memorize them. Okay? Also, there's something on here that we've never seen before, and it's called a positively charged electron, which is called a positron. That only happens in nuclear reactions. There are no positrons in a regular chemical reaction. Now, you don't have to worry about how these things are created or formed. Just know that these are the particles. So, yeah, make sure you know these. Also, and I'll go through some of the reactions here. Let me find an empty spot here. You'll hear the term emission. You'll hear the term decay. I'm trying to find if there's a decay somewhere written. Yeah, I don't see it. But here's what I want you to know. There's the arrow. Okay? If it says that something is undergoing capture, it's on the reactant side. Oh, okay. If something is undergoing capture, alpha capture, beta capture, etc., it's on the left-hand side. If it says that it's undergoing emission or decay, which means the same exact thing as emission, then it's on the product side. Now, I will later on, I don't think I do it today, say, okay, we've got a beta capture with an alpha decay. That could happen. So just make sure that you're keeping it on the respective side. You may want to write this down. So capture, decay, and emission. And it's on the respective side of the arrow. And we'll do some practice problems here. So, all right, so the different types of reactions, and again, these are not things that you will have to memorize, but I want to make sure that you understand what's actually happening. So here again, like yesterday, we were talking about make sure that the values, so like the protons down here, make sure that they're equal on each side of the arrow, and then as well the masses, make sure that those are also equal on both sides of the arrow. That's just the basics and fundamentals of nuclear chemistry. Now, I don't want you to like freak out and go, how in the world is an alpha particle ejected? You're never going to have to predict that. You'll just have to be able to read the questions and say, oh, okay, this undergoes alpha decay. That is what I want you to know. So alpha decay means that you have an alpha particle on the product side. If you have alpha capture, that means that you have this alpha particle on the reactant side. Okay? And then, again, make sure that those values are equal on both sides. Okay. Bless you. Here's a mechanism where I show iodine 131 changing into xenon 131 based on beta emission or decay. What is happening with the mass as we go from here to here? Stays the same. But the number of protons does what? Goes up or down? Increases. And here's why. When we have an electron or beta particle ejected from the nucleus of the iodine, it actually changes one of the things that's in the nucleus into a proton. What do you think it's changing? A neutron into a proton. And that's what's happening. So by this equation down here, it's showing how that's happening. So up here, the mass remains the same because, again, protons and neutrons contribute mass. Well, we have 53 protons here, 54 here, because one of the neutrons changed into a proton, because when we add those up, it equals that. Again, you're never going to have to memorize that type of system. Just be able to look at it and say, oh, okay, so that's what's happened. The mass remains the same. One of those particles in the nucleus has changed. Which one's changed? A neutron into a proton. Not mine, sorry. Okay, here's another example where we actually have carbon 11 and it changes into boron 11. And what has happened here from here to here? So a proton was converted into a neutron because the mass remains the same. Good. That's the type of question that I would ask. That's a concept type question. So I might ask you, hey, what happened? And then give you some scenarios. Okay. And we actually have that down here. So the proton changes into a neutron. Here, don't get too worked up over this. This is a positron colliding with an electron or a beta particle making gamma rays. We're not gonna worry about that. So don't worry about this reaction here. Yeah, we're not making the Hulk today. And then again, here's another scenario where a proton can be converted into a neutron by beta capture or electron capture. So again, just make sure that you're looking at the numbers and make sure that you can tell the story based on that. Ready to do some examples? Let's do some. So let's take a look at the first one. Berkelium, not one of your 52 elements, BK, undergoes alpha decay. So the first thing that we're going to do, BK, and the 250 again represents what? The mass. So we have to go to the periodic table to find out what the berkelium is element number 97. Don't worry about the mass. So 97. And it undergoes alpha decay. What does that mean? Arrow, very good. And what is an alpha particle? And I totally understand that we're just learning it, so it's okay to peek at your notes and see. Good, so it's a helium atom. Okay. So if we have an alpha particle on the right-hand side, now we have some other mystery thing here. So again, we have 97, so it's kind of like 97 minus 2, right? Treat that arrow like an equal sign. So what is the proton number over here? 95, good. And then the mass on top would be 246. So the thing that we're going to focus on is the 95. So, yeah, so Americonium there. So AM, don't need to know the name. And then double check and make sure that those values are equal to each other. And then double check and make sure you actually pick the right symbol. That's all. Okay. Ready for the next one? All right, so Einsteinium, which is ES. Okay, and 255. And then go to the periodic table, find Einsteinium. So there it is. So number 99. And it says it undergoes alpha capture. Now again, these first two examples are with alpha particles. They won't always be with alpha. But if it undergoes alpha capture, what do we do next? Do an arrow? A plus sign, good. Because we're on the left-hand side of the arrow. So an alpha particle, now the arrow. Okay, so what will we have as our proton number on the bottom? 101, and what's on top? 259. What? So go to the periodic table, find out what element 101 is. MD, good old Mendeleev. Okay, so that's Mendeleev's element. Mendeleeum, I think it is. And double check and make sure your numbers are right. Double check and make sure you pick the right symbol. It's just nuclear chemistry, guys. All right, Californium, good old CF. 253, what is it? Californium, number 98. 98 there. And it says that it undergoes positron capture. So what does that mean? A plus sign or an arrow next? Plus. Plus sign. And what is a positron? Good. So it's a positively charged electron. And what are we going to have on the right-hand side? 99 and 253. And you said ES? Double check that. 99. So Einsteinium, good. Isn't that fun? All right, so let's take a look at these types of problems, now you have everything except the mystery, the question mark. What could it be? Now, here's how you do this. Again, look at the values and figure out what those numbers are. Okay. So we have 95 on the left, 94 over here. So what must be on the bottom for this mystery? A -1, good. And what has to be on top? 0. So what is that particle? An electron or a beta particle. So the question mark is the beta particle or an electron. And again, make sure that when you have it done, 95 minus 1 equals 94, 234 plus 0 equals 234. Wouldn't this be awful to have a test today? All right, so again, 0 and 92. Tough. So 239 there. So what are we going to have on the bottom? 90. Okay. And then what's on top? No. What number's on top? 235. Again, 235 plus 4 equals 239. Then go to the periodic table and say, hey, that's thorium, right? Okay, so 90. And then, is this the last one, or do we have 2 more? Oh, we have 2 more. Good. Okay, so what's going to be the proton number here? 95. What's the mass? 244. So go to the periodic table and find out what 95 is. God bless America. And then 13, the last. Okay. So what is on the bottom? Plus 1 because we have a plus sign here. And then 0, it's a positron. It's not you. All right, let me make sure that, or any questions on this? Pretty straightforward. Okay. So the homework is the 2s. All right.